Okay, so I'm really stupid, but I figure out why. So basically, I'll keep that video short. I think my reasoning was going the right way, but my reasoning was going the right way, but I just had misinterpreted these. So the sentence says it evaluates to one, but what it evaluates to one is the probability of measuring zero. So that's how you read this. So let me try to explain that again. So basically, you've by having that initial setup, what you're doing is you're kind of duplicating your input space for the function into two. One is preceded by 0, one is preceded by -1. Then you've got all the different possibilities in here, all the different possibilities in here, but they are the same. So here it's the same as here. So what you're doing by doing that is that by implementing the box this way, is that if the function is constant, right? Let's imagine it always inputs. If it's always 0, then you're here, right? So let's, for the case of like n equals 2, you've got 0, 0, 0, 0, 1, 1, 0, 1, 1, right? So you've got these, and then you've got the second part, which is this one, 0, 1, 1. So this is your two kind of input spaces, so to say. So if it's the same, it's the same. This means really when you do that Hadamard in here, what you're doing is you're ignoring the ancilla qubit, and so really what you've got here is, after applying a Hadamard, let me change color maybe. So after applying the Hadamard, you're really getting a 0, 0, and the same here. So the probability of reading 0 is 1, and that's what the statement in here says. Good. That's it really, because what you're doing when you're and if the function is constant, is always outputting a 1, you're just really flipping the values from one space to the other space, so you're going to get the same, really, because then this is all going to turn into ones. So this will all turn into ones, and this will all turn into zeros, and so you don't care. So, but I don't know why you would call that constructive interference. That's what's confusing me in terms of the way this is phrased in here. There's nothing being constructed, really. You've got qubits that you create a Hadamard, so you create so you create uncertainty, and then you kind of go back to your initial state. But maybe that's kind of, because I always assume constructive interference would be when you tweak the phase in such a way that then certain amplitudes add up, versus destructive interference when certain amplitudes cancel out. And in the case of, let's say, the fx is balanced, right? So what you're going to have is in here, and now let's switch to yellow. You're going to see yellow? Maybe you're red again. Let's go to red. So then what you're going to have is, let's say that for 0, 0, and 0, 1, you're getting a 0, and for 1, 0, 1, 1, you're getting a 1, right? So that's balanced. And so in this case, you're going to get, like, for 0, 0, you're getting a 0, so that stays 0. And for 0, 1, that stays 0. For 1, 0, that turns into 1. That turns into a 1. And exactly. And here, that stays 1, 1, and that turns into a 0, and that turns into a 0, because you're adding modulo 2. So now, if you want to apply the Hadamard, because you've changed the ancilla qubit, now basically you've shifted the phase. So now, if you want to apply you cannot apply the Hadamard any more longer in this block in here. So you kind of mix your spaces. You kind of broke them, and now what you should consider when doing a Hadamard is there where the ancilla qubit is always 0, right? So here, 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 right? And no, sorry, that's the wrong way of explaining it. No. Well, yeah, it is actually. No, it is the right way to explain it. So in the places where, what am I writing? In the places where the ancilla qubit is always 0, right? in this case, and remember the minus is there. So in this case, you've got like the 0, 0, 0, 1, minus 1, 0, minus 1, 1. If we remove the 0, right, because we don't care, because it's always the same. And that is not your 0, 0. That's not the result of applying Hadamard, because that's what we're doing when applying the Hadamard again. Here's you're going back to the original state, and maybe here, okay, maybe the destructive interference happens in here if you really go step by step and you apply the Hadamard here, then you're going to see that there's destructive interference, but that's the same going to happen here. You also see this destructive interference when you apply it in the other case. It's just that it all goes back to one kind of final state or not. But it's never going to be this one. And then for all the cases where you have a 1, you have a similar setup. So you have basically minus 0, 0, minus 0, 1, 1, 0, 1, 1. So that's definitely not 0, 0. So that's what the statement is saying is, for the balanced case, your probability of measuring 0, 0, 0 is 0. That's all it's saying, really. And yeah, it still makes it not straightforward to test as in like in one run, right? Because I mean, you know, if you see a 0, you know that you are in a constant function, yeah, because it's your probability in this case. But that's it, really. It just confused me two things. One is the way this was phrased. I just read this too fast, and obviously I thought that you would output a 1 if it's constant, and no, what you output is the probability of seeing 0 in your outcome is 1. So you always measure 0, 0, 0. That was my mistake. That was my misunderstanding. Okay, but it's a nice way to see that trick of the ancilla qubit and the negativity in here is basically you're kind of duplicating your input space and you're shifting the phases. Exactly, and so you're not coming back to the same place. That's really the trick, and I think it's what Grover's algorithm is using as well, right? So it's like you're shifting that so you're not able to come back to the original state when applying the Hadamard again. So pretty cool, pretty cool. I hope that was helpful. It was helpful for me definitely to come back to this. I'm gonna go and do more of those revisiting videos because that's been super insightful. Perfect.